Okay, so Terry Watkins here can row about 10.6 kilometers in 1 hour downstream and 6 kilometers upstream in 1 hour. So we have to find how fast he can row in still water and find the speed of the current. So the total speed is what we need to look at. So we have the speed at which he's going to row and the downstream speed that we have. So if we are rowing a boat, then when we are doing it downstream, the current is going to help you move the boat faster. In other words, it is going to push you down the stream. But if you're trying to go upstream, you are going against the current, so it is going to reduce the speed a bit. So I'm going to start by defining x. To be rowing speed, and y to be the speed of the current. And whatever total speed that we have downstream is the sum of the rowing speed and the speed of the current, because the rowing speed would be increased, or the speed in general would be increased with respect to the current because you're going downstream. So this would be x plus y. So the speed at which Terry is rowing the boat and the speed of the current combined in total is 10.6 kilometers per hour. So that is the total speed downstream. The upstream speed well, you are rowing against the current, so whatever rowing speed that you have, it is going to be pushed back by the speed of the current. So your actual rowing speed will be decreased by the current because it's going in the opposite direction. So we would have x minus y, and that would equal to 6.8. So now we have a very easy case of linear system of equations in two variables. We know how to solve that. So once you formulate the problem, it really doesn't matter as to which approach you use to solve the system. You can choose to use the substitution method, you can use the elimination method, use whichever one you like. So I'm simply going to use the elimination method. And I'm going to eliminate y. So if I add those two equations, y is going to go away. So we have 2x is equal to 17.4. And divide by 2 on both sides, x would equal to 8.7. So the rowing speed is 8.7 kilometers per hour, because that's what we defined x to be. X is the rowing speed, and y is the speed of the current. We actually found one of the variables, so we've got to find the other one. To do that, we take the value of x we found and plug it in one of the two equations. It really doesn't matter which one you go for. I'm going to go for x plus y is equal to 10.6. So if we plug in x is equal to 8.7 kilometers per hour and x plus y equals 10.6, we have 8.7 plus y equals 10.6. Y would be equal to 10.6 minus 8.7, which would give us 1.9. So the rowing speed is 8.7 kilometers per hour, and the speed of the current is 1.9 kilometers per hour. So here is another problem where, again, we have to translate the word problem into a system of linear equations so that we can come up with a solution for the problem itself. So we would like to find the number of quarts of 4% butterfat milk and 1% butterfat milk to be mixed in order to get 60 quarts of 2% butterfat milk. So what we know is that we need 60 quarts in total. So X be the amount of 4% butterfat milk, and going along the same lines, I could define Y to be the amount of %1 butterfat milk and we know that we need a total of 60 quarts. So that means if I add X and Y, it must add to 60, and that is what we are looking for. So X plus Y must be equal to 60. So this equation describes now the key here is to formulate the second equation. The second equation is a bit of tricky because we're not simply looking at the amount, rather we are looking at the percent that we are trying to form. So how do we do it? So the first equation is for the amount. The second is for the percent. So So 4% of X is going to give us a certain percent of butterfat milk. So we have 4% of X, and we also have 1% of Y. So if we combine the two, which is 4% of X and 1% of Y, we should end up getting a certain amount of 2% milk. So what is that net amount? We know that that net amount is, or has to be, 2% of that 60 quarts that we have. So this would be 2% of the net amount of 60. So we would end up having 0.04x plus 0.01y equals 0.12. So those two describe the strength or concentration of butterfat milk. Some people love fractions, some do not. So we can rewrite this equation so that we can get rid of the, some people like decimals and some do not. We can rewrite this by getting rid of the decimals by multiplying the second equation by 100. So that would give me 100 times 0.04, which is 4x, 100 times 0.01, which is simply y, 100 times 0.12, we get 12. So I have equation 1, which is x plus y equals 20. That comes from the amount of milk that we want finally, which is 60. The second equation comes from the concentration of the types of milk, which would be the 4% and the 1% milk. So since we have the two equations, x plus y equals 60, and 4x plus y equals 12, I can subtract the two, and if I subtract the two, I'm getting a negative number, which I shouldn't. Did I formulate it incorrectly? 2 times 2 over 10. Eliminating y times 10 2 over 100 to, let me check this. This is actually 1.2. Still doesn't help. So this would be 2 over 10, times 60, which would give us 12 over 10, which would be 1.2. So now that we have the two equations, our goal is to simplify, and if I have 1.2 and I multiply by 100 on both sides, I need to multiply the 1.2 also by 100. That is the part that I missed. So this should be 100 here. So when I multiplied by 100, I did it on the right-hand side, but I forgot to do it on, or I multiplied on the left-hand side, but I forgot to do it on the right-hand side. So 1.2 times 100 would be 120. So now we would have 120 there. So x minus 4x would be minus 3x. Y minus y would get cancelled. 60 minus 120 would be minus 60. So divide by minus 3 on both sides, negative 60 over negative 3, which would imply x is 20. Now that we found x, all we have to do is plug in x is equal to 20 in one of the two equations. Doesn't matter which one, so I'm going to pick x plus y equals 60. So 20 plus y would be equal to 60, which would mean y is 60 minus 20, which would end up being 40. So in order to get that 60 quarts of butterfat milk, we've got to combine 20 quarts of 4% milk and 40 quarts of 1% milk to get that final amount, 60 quarts of 2% milk. So in this problem, the place we should start is probably the very last statement, find how many of each type she bought. So in other words, the variables that we have to set has to be the number of frames. So let me just use different variables here. Let L be large frames and S be small frames. So we know that in total, she bought 22 frames. So the total number of frames is 22, which would simply mean the number of frames that we have L plus the number of frames we have for the smaller one, S, must equal 22. So that is our first equation. Now we have to move on to the second equation. The second equation is related to the cost. The total cost that Karen paid is $239. So, and how did she get that $239? So the total cost is $239. So she bought 15 of the large ones and 8 of the small ones. Sorry, I take that back. Unknown quantity of large ones multiplied by 15, which is simply the price per plate. So if she bought one plate, it is going to cost her $15 a large frame. If she bought 2 frames, then it would cost her $30. If she got 3 frames, it would cost her $45. 10 frames, it would cost her $150. So if I pick an arbitrary number, L frames, so that should cost her 15 times L. So if we break it down, this is the cost of which would simply be large. And likewise, we have S number of small frames. I should probably write this as number of frames. Probably make better sense. So the number of small frames is S. So if I paid $8 per frame, then 8S would be the total cost for S number of frames. So 15L plus 8S would be equal to 239. So that would be equation number 2. Now I can use elimination L plus S is equal to 22. 15L plus 8S would equal 239. And we all know that we can cancel out either of the terms. We just have to pick one that is easy to deal with. So I am going to eliminate the variable S. So I can't do it directly. So I am going to multiply the first equation by 8 on both sides. So 8L plus 8S would be equal to 172. 15L plus 8S would equal to 239. And if I subtract the two, I would end up getting 67. If I did my multiplication right. 9 to 39, 20, 16. It's bad algebra. It's 176. Yeah. So the S's would get cancelled, and 8L minus 15L is negative 7L. And there should be a negative over there because it is 176 minus 239. The negatives would go away, or we can simply divide by negative 7 on both sides. Negative 63 over negative 7. Negatives go away, L would be equal to 9. So the number of large frames that Karen bought is 9. Now that we have one of the variables, we can take that and plug it in one of the two equations. I'm going to go for the easy one, which is L plus S equals 22. So plug in L equals 9 in L plus S equals 22, which would mean 9 plus S is 22, and S would be 22 minus 9, which is simply 13. So Karen bought 9 large frames at a price of 15 each, and 13 small frames at a price of $8 each. So in total, 9 plus 13 is 22 frames, and she spent $239. You can verify if the second equation is satisfied. All you have to do is take the value of L and take the value of S, plug it in the second equation, and it would equal to 239. So I guess I could call the numbers as A equals the first number, B is the second number, and what do we know? We know that twice one number minus the second number is 42. So 2 times the first number, A, plus 1 times the second number, B, would equal to 42, which simply means 2A plus B equals 42. That is the first equation. The second part of the question states that the first number minus the second number is 6. So A minus B would equal 6. So the second equation is A minus B equals 6. And it looks like we can directly eliminate the variable b, because one of them's positive b, the other is negative b. So
it'll be -6. Yeah, -6.
Thank you. 2a plus a would be 3a, and b minus b would be 0, and 42 minus 6 would be 36. A would be equal to 36 over 3, which would give us 12. So A is 12. And we just have to plug this in one of the two equations. It really doesn't matter which one you pick. So you plug in A equals 12. I'm going to pick the second one. A minus B equals -6, which would mean 12 minus B equals -6. Minus B would be equal to -6 minus 12. So minus B is -18, which would mean B is 18. So the first number is 12 and the second number is 18. And we can easily verify this. 12 minus 18 is -6. And 2 times 12 is 24, which is the first number, plus 18 is 42. So this would be the last problem in problem solving and system of linear equations. So we have the annual consumption of cheddar cheese, and it has been decreasing in recent years, while the consumption of mozzarella cheese has been increasing. So for the years 2008 through 2013, the function y equals -0.24x plus 10.6 approximates the annual per capita consumption of cheddar cheese in pounds. And the other function, y equals 0.21x plus 10.5, does it for mozzarella cheese. We would like to know, in part B, the year in which the pounds of cheddar cheese consumed equal the pounds of mozzarella cheese consumed. So there are a couple of ways to formulate this. So the first approach you look at the line y equals -0.24x plus 10.6. And the second line, which is for mozzarella, and we can answer part A just by looking at the two equations. So it is decreasing for cheddar cheese because we have a negative here, which means a negative slope. Negative slope indicates decreasing, whereas a positive slope indicates increasing. So the equation for cheddar cheese has a negative slope, which would imply the line is decreasing, so the consumption is decreasing. The equation for mozzarella cheese has a positive slope, which would imply that the line is increasing. Now, the key to note here is to somehow formulate this as a linear system of equations in the first approach. So we know we can take the equation of a line and convert it to a system of linear equations by moving terms around. So in the first equation, I can move negative 0.24x to the other side. So we'll get 0.24x plus y equals 10.6. In the other equation, I can move 0.21x to the other side, minus 0.21x plus y equals 10.5. And now we have a system of linear equations, and we can pretty much solve for x and y. But we want to know what x and y are prior to even solving for the variables. So if you read the question, you will see that x is the number of years after 2008. So if I start at 2008, that would be where you start your measurement, and 2009 would be 1 year after 2008, and 2010 would be 2 years, and so on, all the way up to 2013, which would be year number 5. So the values of x are simply 0, 1, 2, 3, 4, and 5, corresponding to the number of years after or since 2008. So we just have to solve for x, and that is exactly what we're trying to do. But if you look at the question, it says determine the year in which the pounds of cheddar cheese consumed equal the pounds of mozzarella cheese consumed. The goal is to realize that the two lines, or the two functions, which are lines, become the same at some value of x at some year since 2008. And what does that mean as a system of linear equations? We know the solution to a system of linear equations is the point of intersection of the two lines. In other words, both lines would have the same exact value where they meet. So if you solve this system using the first approach, I do have space, okay. So since we have the system, I'm just going to go ahead and eliminate y. So I have 0.24x minus 0.21x plus y. And I can subtract the two equations. The y's would go away. 0.24x minus 0.21x is 0.45x. 10.6 minus 10.5 is simply 0.1, which would mean x is 0.1 divided by 0.45, which, if you simplify, it is going to be 100 over 45. That will be 2.2 approximately. 2.02, I believe. So I can round it to the nearest integer and call it 2. So we found x, and x simply is the number of years since 2008. So the year in which the pounds of cheddar cheese consumption equal the pounds of mozzarella cheese consumption would be 2 years since 2008. So that would be the year 2010. But but is this the only way to do the problem? Well, this is one of the ways to do the problem. What is the second approach? We know that the solution to the system of linear equations is the point of intersection, as I mentioned earlier. It is the value where the two functions would be the same, or will have the same value, as I mentioned earlier. So the second approach is where you set one equation equal to the other. So we have equation y, and we have the second equation, 0.21x plus 10.5. So this is the amount of cheddar cheese. And that is the amount of mozzarella cheese. So since we know at some time x, the amount of the two different types of cheeses were the same. That is negative 0.24x plus 10.6. The amount of cheddar cheese equaled the amount of mozzarella cheese. So they became the same. So if I rearrange it in the sense, move all the x's to one side and numbers to other, 10.6 minus 10.5 would equal to 0.21x plus 0.24x. And the right hand side would be 0.1. Sorry, left hand side would be 0.1. Right hand side would be 0.45x. We can solve for x, which should simply be 0.1 over 0.5. You can say that this number, or whatever we have here, is exactly the same thing that we had over there. So only this approach is a bit easier than the other one. So the answer again would be approximately 2 years since 2008, which would mean the year 2010.